Hi viewers, today I want to look at an important topic in our solar system. That is how to size solar charge controller. How do you know the size of solar charge controller you need? Solar charge controller is an electronics device that regulates the electricity that flows from the solar panel to the battery. Now, solar charge controller, in our previous video, we have explained it extensively, but today we want to look at how to design it. It's rated in amps. We have 10 amps, 20 amps, 60 amps, as the case may be. Now, today, we want to know, in this your installation, you need 60 amps. In this your installation, you need 20 amps. In this installation, you need 120 amps. We want to look at it today. Alright. Number one thing you need to do is that you take the data of the load in the house. And that is where we come with this data. Now, number one here is double door freezer. It's one piece, 800 watts, and the total wattage is 800 watts. Ceiling fan, we have two pieces. Each one is 120 watts, and the total 120 watts times 2, we have 240 watts. We have electric bulbs. We have 20 pieces and 10 watts per one. You see that we have 200 watts. We have laptop. 3 pieces of laptop, 100 watts. We have it 300 watts. Television, 2 pieces of television, 100 watts. We have 200 watts. And 1 horsepower AC. 1 pieces and what? 745 watts. 745 watts. And in this, as we have run it in a tabular form, you will see that we have the total energy consumption is equal to what? 2,500 watts. In this 2,500 watts, convert it to kVA. That is to say, you divide it by 1,000. Converting this 2,500 watts. Converting 2,500 watts into kVA. It will give you 2,500 watts divided by 1,000. That means you have is equal to 2.5 kilowatts, which is what? 2.5 kVA. And that is what we have here. 2.5 kVA. Now the total load is equal to 2.5 kVA. And the load will be on for 12 hours. At this time, the load will be on for 12 hours. That at night, when it's not receiving any charge, it will last, expected to last for 12 hours. Now, at this point, when it will be lasting for 12 hours, you are expected to calculate the total watt hour. And how do you calculate the total watt hour? This is our total load has to be multiplied by that total hour. That is to say 2.5 kVA. Kilowatts multiplied by what? 12 hours. As you can see it on the screen here. And the answer it will give you is what? Is equal to 30 kilowatts hour. Of course, you know that this is the size of the battery needed to run this load for what? For complete 12 hours. So now, the energy consumption per day, the average sunny hour, that is where you look at the region where you are. The energy consumption per day, the average sunny hour of the area, most especially in the country today, or most of the places, we normally have up to 5 hours from 11 o'clock, 12, 1, 2, 3. That is 5 hours. And if you take it from 12 by 4 o'clock, that is 5 hours, when the sun will be at its maximum. And you are expected that this solar system has to charge it within this space of time. You need to be charged full. Now, you have a little calculation you need to make. And that is to say that as you have this 30 kilowatt hour is equal to what? 30,000. 30,000 watts hour. So, if the watt energy, I mean sun energy, we have sun hour, 5 hours. If our sun hour of the region is equal to 5 hours. That means we need to divide this 30,000 divided by 5 is equal to 6,000. Now, as you have this 6,000 as your total wattage of your panel, total wattage of the panel unit, you have 6,000. You have 6,000 as total wattage of the panel. Now, having this 6,000, you realize that, and we are using 420 watts. Now, assuming we are using 550 watts solar panel. Now, how many pieces of this solar panel do we need? When our total wattage is going to be 6,000 watts. Therefore, divide the total wattage of the panel divided by what? The individual wattage of the panel. That means this 6,000 now divide by what? 6,000 divided by 550. We have what? 10. We have the answer is equal to 10. That is to say that we need that is to say we need 10 pieces of solar panel, 10 pieces of 550 watts solar panel for this installation. Now we need 10 pieces of this solar panel for this installation. The system we have is 48 volts system. And this system we have, that is 48 volt system, we are looking at how to size your what? Your charge controller. Now, having gotten these 10 pieces of this solar panel, each of the solar panel is 69 volts and 14 amps as current. Now, since we are having 69 volts and 14 amps as current, if your system you are using is 48 volts in series connection, you realize that the voltage is adding up. And when this voltage adds up, it will be this plus 69 plus 69 plus 69. At the end, you will have 690 volts. While the amps remain the same if you connect them in series. And that is to say that your charge controller can actually go 20 amps, can actually go. But it's rare to see the connection, this configuration in your system. Therefore, what you need to do is that if your charge controller, your system is 48 volt system, what you need to do is that you connect these 10 pieces of solar panel, connect 2 in series into 5. So the 2 you connected in series give you the voltage. The output voltage is going to give you what? 138 volts. From what I've done so far here, you realize that this 2 is connected in series, this 2 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 connected in series. You bring them together and connect all of them in parallel. Now, as you connect this in series, remember that this, so between this block, between this block, what we have is 139 volts, 14 amps. The same thing we have it here, the same thing here, the same thing here, and the same thing here. So as you have these two like this, that is to say that as you connect them in parallel, your voltage will remain the same. Output you have 139 volts. Now, remember that as you connect them in parallel, the amps is increasing. That is to say that this is 14 amps, 14 amps, 14 amps, 14 amps. So 14 plus 14, 28. 28 plus 14 plus 14, that is 28 plus 28. We have 56. 56 plus 14. 56 plus 14, we have 70. So the output here is 70 amps. That is to say that our output current we are looking at here is 70 amps. Therefore, for the amps of your charge controller, I've earlier told you that charge controller is rated in amps. So the charge controller you are expected to use is minimum of 70 amps. Now, in a solar system, you cannot design and without a tolerance. That means if you design without a tolerance, that system will have issue because the sun sometimes increases, and as such, you are expected to add 50% of the tolerance. Some people add 20% of the as tolerance. Some people 30%, but I normally use 50 to be on the safer side. So 50% of this, 50% of 70 amps is equals to 0.5. Now, 0.5 multiplied by 70 is equals to 35. Plus 70 is equals to 105. Therefore, the size of the charge controller you are expected to use is what? 105 amps. Yes, this is how to calculate the solar charge controller of your inverter system. Please don't forget to subscribe, like, and share. Thank you.